Okay, this is example number 3 of section 14, 1, 2, 3. So we have a 2-block brick that slides down a smooth roof. So this is a smooth surface with a velocity of 5 feet per second. So we have an initial velocity known feet 5 per second. And they want us to find the speed at point B and the speed at point C and the distance from the wall to where it hits the floor. There are several ways to solve this problem, but we will solve it using the principle of work and energy. So the solution, so as you know, there is several ways to write the principle of work and energy. The way I like to write it is that the work of non-conservative forces is equals to the total energy in the second position, so which is kinetic energy plus potential energy, minus the total energy in the initial position, which is kinetic energy plus total potential energy. So we have to look at our problem and see if we have a non-conservative forces. And when we read the question, we see that it's a smooth roof. So we don't have any friction. And we see that the forces that we have is the weight, and the weight we can treat it as a potential energy and velocity. So we know that the work of non-conservative forces is equal to 0. So we have kinetic energy plus potential energy in the final position, or the position B, is equals to kinetic energy plus potential energy in the initial position. So let's calculate all this. We start with kinetic energy in point A. We know the velocity, which is 1/2 mass velocity A squared. Remember that in American units or in the British units, the pound is the basic unit and mass is a derived unit, right? So we have to take our pound, our weight, and divide it by the gravity to get our mass. And the velocity is known because we are told that it's 5 feet per second, so this is square. Then I have the potential energy in A. Between the potential energy in the initial position and the final position is a difference. So we have to put a datum, a reference plane. So I'm going to put my reference plane over here. So if this is my reference area, I do not have any accumulated potential energy right there. So I will say this is 0. Then I have the final kinetic energy, which is 1/2 mass velocity at B. This is the one that I want to find, so this is an unknown, which is then 1/2, 232 times 2, velocity B squared. And then I have the potential energy in B. Now, since my reference frame is right there, and I have to use the same reference datum for both position, initial and the final position, then I do have an energy, a potential energy drop, because I had lost potential energy. How much did I lose? The potential energy will be mgh. This is the weight, and this is the h that I lost, which is 15 feet. So that will be -2 pounds times 15. So I just plug all these values right here, and instead of calculating, I can do my equations and I will calculate everything. So I will write 1/2, well, this 2 goes with that 2. So I have 1/32.2 B squared plus, minus actually, right? Minus 215 will be equals to 1/2. This goes also 1/32.2, 5 squared. And the only unknown that I have is my velocity in B. So that will be, I can solve for B, and I have the answer right here. The answer will be 31.48 feet per second. So that's the velocity in B. To find velocity in C, we apply almost the same concept. We can apply the principle of work and energy from A to C or from B to C. That will give us the same result. We just need to know if we use from A to C, we lost that much amount of energy in potential energy, and if we use the velocity in B, we will have to use this amount of energy. So I actually will use exactly the same that I have here, and I will say to find, so this was question number 1. Question number 2 is to find velocity C. We use that C plus VC is equals to TA plus VA. We already calculated all TA and VA. TC will be 1/2 mass VC squared, and VC will be negative. Now I lost all this amount of energy, so it will be my pound, which is 2, times, instead of 15, will be 45. So I plug those values in here, and I have 1/2 of 2 divided by 32.2 velocity C squared minus 2 times 45 equals to TA, which I have it right here, which is 1 over 32.2 VA squared. And the potential energy, I remember this is a capital V, is potential energy is 0. So from here I solve for VC, and I have the velocity, which gives me a value of 54.1 feet over second. So that's my second value. And the third question, so we already found the speed of C, the speed of the speed at B, the speed at C, and we need to find the distance from the wall. So where does that brick hit the floor? So distance, to find the distance in, I will just use kinematic relations. And I know that for that distance, x in C will be xb plus. So I have, here I will have 2 unknowns, right? Because I'm going to put my coordinates right here. So this is x, y. So xb will be 0. That's where I start. And xc, that will be the d I'm looking for. But I have velocity, I have it, but I don't have the times. So here I can say that d is equals to vx. Vx, I already found v, but v is a velocity in this direction, right? This is ve. And I like velocity in v. This composed in velocity in vx and velocity in vy, right? So that will be velocity in v times, I know that angle right here, so it will be the cosine of this angle, which is 4/5 times t. And then I apply my equations in y. Why in y? Because I do know the acceleration in y, right? So we remember that yc is equals yb plus vyt from b to c minus 1/2 gravity, because the gravity is negative, we know that also, right? Times tbc. Say this is 0, and so this is minus 30 equals that b times 3/5 tb minus 1/2 32.2 tbc squared. So from here, as you see, I know the velocity in v because it's right here. I solved it already, and so from here the only unknown that I have is the time. So I will solve for time, which gives me 0.899 seconds. And then I substitute that in the first equation. Then d which is equals to V D. Well, I'm going to already substitute, so for you to know that I'm using this variable 31.48 times that time that I just found, and then I get that the D is equals to 22.6 feet. So just to review, we use the principle of work and energy to find both as velocities in B and C, and then we use the kinetic relations in X and Y. In X, we found a relation between the distance and time. This time is the time that it takes to go from B to C, and then we use the relations in Y to find time, and then plug it into here. And we found the time that it takes from B to C and the distance in the horizontal direction where it hits the ground.